Tester.co.uk. Hello YouTubers, and welcome to part 2 of the Fluke 115 review. Now in this review we're going to open it up, have a look inside, just check what the build quality and the input protection is like. We'll also look at the battery consumption and whether the low battery warning light comes on at the right time. And then afterwards we'll do some mains measurements, so let's get down to the bench and do that. Right, the first thing I thought I'd do, as I didn't directly do it in part 1 of the testing, is just to quickly check the auto ranging. So here we go, 1, 2, 3. 1, 2, 3. Reasonable. Not too slow. Some might be faster, but that's certainly not bad. Right, so I'm going to now take it out of the holster. We'll have a look at the actual multimeter out of the holster, and then we'll start to take it apart. So the holster itself is fitted quite solidly. So here we go. Here's the little beastie. The holster itself, it doesn't have some of the ribbing in it like, let's say, I think the Fluke 87 has, but certainly a nice quality feel to the holster itself. The actual meter, even out of its holster, is fairly good looking. Some meters, once you take them out the holsters, are quite ugly because the actual holster is an integral part of the design, but certainly not a bad little meter. Again, the nice integrated stand on the back, a good solid feeling and nicely attached to the back of the meter itself. So let's open up the battery compartment and see what that looks like. Right, so I've just popped out the single screw which actually goes into the battery compartment. There is a metal receiver over there, so that certainly is nice. Now I just want to open this to see the ease of which it opens, or okay, I was going to say or lack of ease, but certainly seems to open up nice and easily. A very nice arrangement for a battery holder, a 9-volt battery holder. So it's obviously got the connectors soldered right onto the board itself, which is nice and solid, and a nice arrangement with the battery, far better than those silly clippy things. And obviously the standing bell comes off with that. Right, so we'll undo the rest of the screws and get inside. Right, the self-tapping screws are out. Nice, solid, long self-tapping screws. A nice feel when they came out. It didn't feel as though it was coming out of plastic, which was not going to take again. So let's just pull it open. Now, I'm not 100% sure of the arrangement here. My goodness, I've obviously not taken this apart before. I'm assuming it's obviously only got these 2 screws here. I'm assuming it's plastic clips over here. I cannot see any screws hidden away, but it's certainly, I am concerned about going too far beyond this point. So I'm just going to go have a quick dig myself to make sure that I can crack it open without damaging it, because it certainly feels like I would have liked for it to have released by now. It almost feels if I go beyond this point I might be breaking something, but I'll come back to that. So there we go. It's quite odd. Many of the multimeters which I've opened up with a clip at the top here seem to come apart easier, and it almost had the feeling that it might break, but there you go, it does come apart. It just needs a firm pull apart, and then obviously the plastic tabs over here released from the actual top itself. So here is the bottom part of the case. It's got, okay, that's interesting just to note, it's obviously got a little holder here to make sure that obviously sits over the actual fuse itself. Obviously in this multimeter, just one fuse, HRC fuse, and a very simple layout by all accounts. It does have input protection. It's got a resistor network under here behind a little shield. Right, so I thought I'd just reposition the camera to try and get a better view if possible. Certainly the inputs on this seem to be nice and solid, obviously screwed into these plastic columns on here and then soldered onto the board in 4 places. They've got 3 MOVs, a limit resistor, and a PTC. The board now, remember this board, these are produced in China as opposed to the States. And I must say, from my eye, the quality and the build on this looks really, really good. It looks like a very nice, clean, solid PCB. I'm actually just looking at the camera and it looks a lighter green, but it's actually a bit of a darker green to my eye. I see it's got a tab over here which for a switch, which I presume has got something to do with calibration. So I wonder if I should, okay, no, I won't on this one. And then we've got the buzzer up here, and then this plate which is held on with a couple of screws. So let me just undo those and see what's underneath there. Right, the cover plate comes off easily enough. As you can see, just 2 catches on the side which go into the holes on the board there with the screws. And then it reveals the rest of the board, which of course, unfortunately, I'll take some good high resolution photographs and put them on my forum. But this will be for the benefit of those who are wiser than I am in terms of understanding what the bits and pieces are there. But I can certainly say I really am impressed with the quality of what the PCB itself, and the soldering is all very clean. You know, for most boards that I see that are reasonably good quality, here and there you might find a little bit of sloppiness perhaps in the soldering, but here it does seem to be really, really clean. The other thing I forgot to point out is here is obviously the current shunt, and that also seems to be nice and clean and neat. So I will now proceed to remove the screws on the inputs over here and that one, and I'll see how much further we can get. Right, and what I thought I would show is I'm going to crack open one of these screws on camera. There's no spring washers or anything of that sort, but as you can see with the blue kind of paint on the screws, that it's obviously got a Loctite on these, and they're holding very firmly. I've got a good size Phillips screwdriver, and there we go. You heard that crack, and that took a lot of effort to actually get that loose, so I don't think it would come loose in a hurry anyway. Right, and just a note, if you were going to be taking this apart yourself, which I say if you're unsure of what you're doing and you're worried about warranty and damaging your equipment, then certainly don't. But there are these little points on the PCB over here, where if you get a nice bodge or something, it just very gently fits under and loosens it over there. I'll attempt the same on this side. As you can see, the plastic clip is right there. And I'm literally just going in there, and there we go. Literally the board has just popped out as easily as that. Let's have a look, see. Something else holding it. I have missed a screw. Silly me. Look here. Scotch mist is what we'd call that. Okay, so it came out relatively easily once I had all the screws out and just flipped it out. I will just note that as I was lifting it out, you'll have seen I was holding on the terminals to lift it out, and I felt a little twing. I don't know whether it was just a little stiffness or what have you, but just be wary of that. The last thing you want to do is obviously break these off the PCB itself. I'm having a look. I cannot see any damage, but just to be wary about that, obviously. Okay, and there we have the other side, and again, very clean looking. It's always nice to see the displays that are packed together like this and held together properly. I'll just show you the underside, the other part of the case. Obviously the nice solid inputs on here. I really do like it when meters like this have a nice solid arrangement for the inputs. What's just dropped out? A little plate around the input selector. A nice solid and easy working selector switch and a nice screen. I must say I really do like the build quality of this. And it actually kind of frustrates me that the thought that comes to mind now when I see the build quality, as you can see, it's got a nice slot around the side to contain any minor environmentals and obviously anything, if anything goes bang inside. And what frustrates me is that this has got such a nice build quality inside, and the input protection seems certainly to be up to scratch. But then why does this display let it down? It blows me away that companies like Unity, which obviously make cheaper meters, and I know some people will challenge me when I say the build quality certainly isn't as good, and I think a little bit tacky, but you're paying a far cheaper price. But their displays are really, really good. They're gorgeous, they're crisp, and I don't know why the display on this Fluke, and certainly others by other accounts, just isn't up to scratch. It does obviously have these high voltage slots cut in the board as well. Really nice, simple layout and clean. I certainly must say it's one of the nicest I've seen. Right, and I thought I'd just pop off the display. There's just a little plastic clip and then 2 points here, and then obviously the zebra connector just goes onto the board over there. So that's the display itself. I'll just carefully hold it. Don't want anything to fall out. The strip is kind of in a slot over there, which seems like a fairly nice robust arrangement, so it doesn't fall out too easily. And then we've obviously got the connector across the top of the board there. Seems to be, is that a diode? Oh no, that'll be the LED, the light emitting diode on the board, which would explain that hot spot in the display because it's got that little diode over there. Okay, right, time to put it back together. And then just to note as I'm putting it together, because I hadn't realized the position this extra cover was, as it kind of just dropped out, it just fits neatly over the selector mechanism like that on the board. And then on the top half, I pointed out the high voltage slots which are cut into the motherboard, and on this end you've got these which obviously go in between to add some more separation on which poke through on the other side of the board. Again, something just to note just before I connect up the variable power supply is that I've got it screwed up. I've got the self-tapper screws, which obviously go into a nice good quality plastic, so certainly no concerns about it stripping a good solid bite when you put them in. And although it's making use of plastic clips at the end here, a good solid clip in, and the seam is held nicely. Unlike recently, when I reviewed the amp probe, it had screws down here and relied on a plastic clip, but that certainly didn't hold the case in nicely, but not the case on this one. It's nice and solid. Right, so we're just about to do the test for the low battery warning. I've got the cheaper Chinese market produced Fluke 17B here. As you know, they've also got an international version now to compete at the low end. I will be doing a comparison between these and some others because I think there are some interesting lessons to come out of this. But I just want you to note with these even side by side, which display do you prefer? The one on the expensive 115 or the one on the 17B? I'll leave that for you to decide. Right, we're at 9 volts on my variable power supply, or just over. I'm going to drop that. Of course, it always helps to have a reference attached so that we can see how the voltage is going, but we've got it attached to the reference 499. Let's just take it up to 9 volts again to make sure we're not cheating. Okay, so what we're hoping to see is that it maintains that while the voltage drops until we see the battery annotation. Okay, so they're at about 5 volts. I can just see the battery annotation has come down on in the corner. So I'm going to go back up. Okay, so at 6.2 it went off. About 5.5 it comes on, so that's not too bad. Let's see what happens. That's what we like to see. A nice warning, it's not going to show you a measurement below this point. Let's see it go down and the display goes off. Great. So that's what we want to see. So next we'll check the battery consumption, but before we do that, let's just quickly see, does it come back on when the voltage comes back up? Yep. It restarts and it comes back. And that goes. Okay, perfect. Right, we're ready to measure the consumption. I've got it all wired up. This is obviously going to measure the current consumption. So if we switch it on, we're running it obviously 9 volts and 1.3 milliamp. That's certainly not very high at all. We'll just quickly flick through 1 milliamp on the DC voltage, 1.3, 1 on the DC, on the resistance 1.9. I'm just going to connect 1.43 when shorted. Continuity buzzer 3.87. Diode just on 1. So when I'm shorting on the diode, 4.29. And the current, I've obviously got the leads wrong. You saw it said lead. And there we go. We'll just go back to the resistance. I just want to go through some ranges. Back to manual. Okay, well that certainly doesn't seem too bad. Let's just go back to DC volts and just see with the backlight. And that obviously pops up a little bit higher, but still not too bad actually. So from that it should get a fair amount of life out of a 9-volt battery. Right, I've got the mains here. I'm going to select the first one, which is obviously mains AC. Going to plug in the AC, and there we go. Remember, it's true RMS, but it's a sine wave, so it should measure that fine. But it is true RMS, and no problem there. It's got a little annotation, a little Thunderbolt annotation over there to warn you that obviously you're potentially measuring a high or dangerous energy source. So that's fine. I suppose the next test is to take it through to resistance, see if it survives that. Leave it there for a while. No problem. Check frequency. Nice and easy, intuitive to use. And there we go. So it measures that correctly. So no problems there. Now do just remember that test of flicking through to resistance while you're measuring mains is not a good idea. It's just a check to see if it would survive a move like that. Almost in any multimeter manual, they're going to say you first need to select what you want to measure and then take your measurement, and you don't change the selector while you're taking a certain measurement, because that can potentially end in a problem. Right, so which one of these would you go for? Now that's going to be our next quest, because I think it's going to be an interesting comparison of the meters kind of in this range. But how do we feel about the Fluke 115? I'm perhaps more frustrated by it now than when I first got it and even starting this review, because it does have a very good build quality. The input protection and everything else seems to be very good on this little meter. What lets it down for me, obviously, as I've noted before, is I think the clarity of the display, whether it was an age thing or it's originally like that, and that it doesn't have milliamps or microamps. Now Fluke have obviously got the Fluke 17B, which they're now going to sell internationally to hopefully fill that gap, because this was their low-end multimeter which they sold internationally, but it's expensive and it has those flaws. They have the 17B, but the 17B is a 4,000 count. It's still not cheap, and it's got some limitations in terms of, let's say, its capacitance measurements. So I think it's going to be a very interesting shootout with the others. I think particularly pitted against the Fluke 115 is the Agilent 1232A. I think is going to be a very interesting review. So certainly keep an eye open for that. And if you do gain any value from this video at all, please give it a thumbs up, and I'll catch you soon for the next review. Cheers. Tester.co.uk